Okay. It's Monday morning, 8:55 a.m. I'm still coming off a binge of watching Apple's Severance. Utterly unnerved by, thank you, Tramell Truman portraying the character Milchek as a dystopian middle manager with kind eyes. I settle into Bird Rock Coffee, latte in hand, open up Slack before stand-up, and what is this do I see? 49 messages in the Red Alert channel, several app mentions, and a new ticket opened with me as the assignee. No sweat, we can handle this, bugs happen. And then I see it, the stack trace. It's that function, again. The cluster of branching callbacks and complexity capable of souring a perfectly fine morning. Hello? Oh, did it not? Cool, that's okay. I'm AJ, a DevX organizer around here, and welcome. If it's your first time or we haven't met, glad you're here. And also if we have met and it's not your first time. Here's our roadmap. We're gonna do some goals, a definition of state machines, how we can use, or general use cases for state machines, some examples, and finally, a demo. So goals. Well, it's not even doing my slide stuff. Dang it, that's okay. I know what to do. I don't know what to do, actually. Well, just imagine there's more text there. It's because it's on my screen. So. Whoa. The goals are to add finite state machines to our proverbial tool sheds, try out some new tech, and have a good time. Definition. Nah, still not working. You can define a finite state machine as a set of states and a set of transitions between those states. That's our abstract definition, but we're going to do some examples right now. First example, a switch. Could I have a volunteer from the audience? Go ahead, you beautiful gentleman. Here's this. You can see the button, and when I tell you, press the button. Press it.
You know?
Yeah. There you go. We just toggled from off to on, and go ahead and press one more time. Oh, I guess it gets brighter. Shoot. Thank you, my lovely assistant. You just saw it go from on to off now. And that was?
A finite state machine.
You bet. Thank you. Thank you. Thank you. Everyone give a hand. Oh, what a wonderful man. Example 2, more abstract. I don't have a traffic light with me, but you can find them outside. Starts at green, change transition to yellow, change transition to red, and go back to green again. Something we see every day. And yeah, that was great. Abstractness. Anyways, can I have another volunteer? Buddy in the back, come on, come on. Give him another hand. Here is a drill. You're just it's not loaded, don't worry. Here's our next example. Notice a few things. It has a couple states. It's one of those cool drills where there's like a lock state, and then you press this little thing on the side, and it becomes, you go ahead and do it, yeah. And now we're in clockwise mode, I think. It depends on what, direction you're facing. And then go ahead and press it back this way. You did it twice, and that's good. One more time.
Wait.
Other way.
What?
Did it turn off? Anyways, here is the state of that drill and its transitions represented in a diagram. So. Go ahead and press left.
Like?
The thing in the middle. Oh, yes, you're already on.
Yeah, we're on this one.
Oh, good. It's hard to tell from this direction. Go ahead and pull the trigger. And now we're in drilling state, probably clockwise. And then you released it, and we entered back into just like a ready state. Now go ahead and press it so it's locked. And there we are, we're in the lock state. And so, a little more abstract, a little more fun. Thank you, Tristan. Yay. Couple of notes before we move on. Notice that when it's in the drilling state and you pull the trigger, there's a light. You might say that is a side effect. Upon entering the drilling state, the light turns on. Upon exiting the drilling state, the computer turns off. Let me just fix it, you know. I know it's me. I know. Caffeinate, and we're good. Yeah, so there's a side effect upon entering the drilling state. And under certain conditions, so you put a drill bit here and hook it up to a, that sounds so weird, touch a screw to the drill bit. As you can tell, I am a handyman. Yeah, touch a screw to the drill bit, turn it, and another side effect would be maybe you get shelves on your wall. Yeah, you could say those are both examples of side effects to transitions. Okay, final example. Oh, did it not even? There we go, there we go. This is a little bit something we can actually use in our careers. Magic link authentication. You know when you sign into a website and it's like, check your email for the code, and you go back and enter the code? Has anyone done this? Good, good, lots of nods. We're gonna go through this diagram, I guess. So type in your email, and then you finish typing, then you click the send email button. We transition to the sending email state where there's like a loading thing. And then depending on the success or failure of that, we either go back to entering the email saying, you typed in your email wrong probably, or we go forward to enter the code now in your email. If you successfully enter the code, or you paste in the code or whatever, and then you see a button and it's like verify code, and you click verify, then we'll go to the verifying code state, another little loading thing. And again, if you fail, you go back. And if you succeed, you get to the completion state. Notice how you can't really get back out, because why would you? You're already logged in. So that was the overview of our state machine. And now we will go to the code. Get ready. Like this? Does that work? Oh, good. Yeah, that's great. That looks amazing. I'm just kind of zoom in. No? Am I? Do I know how to use a computer? I don't know. Ah, there we go. That's beautiful. So this is a representation of the diagram we just saw. There's the states. Oh, states are here. Entering email, sending email, entering code, and so on. There's the transitions or events. And there's one special event that takes an argument. We're going to get to that. And then we pass it into a class that will be our state machine. Here are the states at the top. And you can also see again the transitions between the states right here. Ta-da! And completes empty, just like the diagram. Okay, and now I will change the way the screen mirroring works so I cannot turn my head again. Stop extending. Choose content. Ooh, entire screen, perfect. Start mirroring. I narrate this because it helps me. There's my code. Okay. So, first step, we have our outline from our diagram. And now we shall create a little bit of state that we're going to use in the side effects. First one is email, which is going to be a string, empty string first. Second one is going to be error, in case there's some errors. Give it a type of error or undefined. And third one is code, which the user will enter after they get their code in the email. Okay, some 3 items of state outside our state machine. And now we're going to use those side effects that we mentioned earlier with the drill-in. So send email. Upon entering the sending email state, we will do a side effect where we kick off a request to send email, send authorize, send magic code, there we go, to said email. And then, if we succeed, we're gonna tell our machine, hey guys, we succeeded, success. However, if we fail, oh wait, is it not? Oh, it's email, there we go. Okay. If we succeed, we'll send a success transition, and then if we fail, we'll go to the error state. Send, oh wait, machine.send fail. I think fail is a pretty good word for failing. You could use error too. There we go, types work out. So first step, we enter the sending email state, and as a side effect, we kick off the send magic code authentication thing. And then we shall start doing the UI, actually. The UI should be, we'll need an input for the email. So type email, and then we're going to bind that value to the email. And we're only going to show it if the machine state is equal to enter an email. And if. And then we're going to add a button to send it. Get ready. Send email. Oh. What? Anyways.
What's that state diagram?
And this is our failure state. Thank you. I get to this state often. And you know what? I think you guys get it. Let's just go directly to the, the post-turkey state. Like you guys watch baking shows where like putting all the ingredients and then you get all ready to put in the oven, and then suddenly they're like, and I have this other turkey that I already cooked. So we're gonna do that right now. So let's go back from smoke and mirrors to master. Whatever. I want to save it. Git commit whip. You guys do this? You whip out commits? Work in progress? Okay, let's try this again. Oh, that's my slides. I need to start the server again, and then copy that link, and then open up our window, localhost. There it is. There's our big turkey. So you enter your email, send the code, check your mail, copy the code, paste the code. We're logged in. And you can see all that code in 1 second if you wish. It'll be in GitHub later. But the finished product looks like this. And as you can see, there's error handling in the fail event. Same thing we already wrote. And when we enter the verifying code state, we kick off a sign in with magic code request. And here's the UI, which you already saw. Anyways, that was my TED Talk. Sorry, 1 second. I need to thank people. You know, like you have that thing at the end where you thank the people you copied. You know what I'm saying. There we go. So Svelte FSM and Talk by Ken Kunz, Rune by Huntabyte, and Electricity by SDG&E. Thank you.
All right. Check, check, check. All right. Great talk. Awesome job. We have time for some questions. If anyone has any questions, please feel free to raise your hand. Does anyone have any questions for AJ in his talk? In the back. Sure.
So the idea for the state machine is like if your state becomes so complex, you can't keep your business logic and a few conditional ifs and stuff, you should bust it out into a larger diagram like you did and then implement the machine pattern. So I was just curious, is this kind of like XState and other libraries where they have complex state management, and is that the kind of situation where you would use this pattern? Thanks.
Did you mute it? Switch the switch on the.
Is it the switch?
Oh.
I know it's my first day, but still.
Ezekiel, you're a treasure. I'm sorry for doubting you. Speaker state. Bro. Yeah, XState is designed for definitely more complex use cases than that form component right there. But yeah, I think you had a really good summary. When you have a bunch of complex logic and you're like, I don't like this, then maybe a state machine could be your go-to. Good summary. Bro.
All right. Any other questions? Looks like we got one over here.
So for the side effects, is there any way to handle, like, let's say you had a side effect where, like, yeah, you're going from entering a code to sending the from requesting to get an email code to getting an email code. That state, there's a potential to like timeout if the user is not having internet. Are side effects, like, are you able to have timeout logic or like make them basically asynchronous?
Yeah. I mean, wasn't that, sorry, when we did enter that effect and then we kicked off that communication with InstantDB, there was like a catch error clause. So, you know, takes time and could fail.
I guess my question was like, well, so the way you implemented on the UI was like you literally have a state that's like the entire state goes away, and then you can't interact, you can't change a state while it's pending state. But if there was like a more complex UI, like an actual login form where it's like maybe the cancel button's disabled, like you could code that in, I guess. But sometimes it's like can be confusing where if you're waiting on asynchronous state and then the user can see a button that can then try to change the state again, you're having like complex flows. So I guess it was just more of an idea of like, I don't know how you would handle that.
I would maybe make it the button that you're talking about disabled if it's not a certain state, I guess. Yeah, I guess I would change the disabled attribute on the button if it does not match or matches certain states. That was a good answer.
All right. I think we have time for probably one more question. Okay, and then I will take that time because I had one question. How do you determine how do you distinguish in your graph if you're starting with your model of your state machine? How do you determine what would more appropriately be a side effect versus what will be the state from a transition? I guess does that make sense? Like if you think about you're moving a transition from one state to another, A to B, how do you know that B hold your state versus creating a side effect in that transition, which inevitably ends up in a state B? Does that make sense?
I think so. I think I found that you just kind of do intuition. That was my experience.
Do what works. Okay, gotcha. Cool. Well, let's thank AJ for his talk. Appreciate the talk.